My name is Byung, and I'm the current director for the blockchain team. And Jenny, I just start presenting, right?
Yeah, you can totally. And again, you're fine with us recording?
Yeah.
Perfect. I just want to make sure. Ooh, pretty slides.
Hopefully everyone can see this.
Yeah, I can. You should be good to go.
All right. So in this presentation, I'll be giving a very high level overview of Solana blockchain.
Oh, Jordan Wheeler noted that we see your browser and not your presentation mode.
Okay. Thank you for that.
Yep.
So here's the rough outline. It's pretty straightforward. I'll be going over the architecture, the consensus mechanism, and programs, which are they're the same thing as smart contracts in Ethereum, just different names, and as well as hurdles. So Solana has been marketized as the Scalability maxi blockchain, and it released in April 2019, created by Anatoly Yakovenko. And as the title says, it mainly aims to solve the scalability issue that exists in the current blockchain industry. And so far, the blockchain is currently in mainnet beta. So it's not, the mainnet is not, it's still in beta. So there's still a lot of things in development. All right, let's go over how the block propagation works in Solana blockchain. So Solana uses a hybrid mechanism to propagate its blocks. It uses proof of stake and proof of history. Now, proof of stake is pretty relevant in recent blockchains. Ethereum has moved away from proof of work to proof of stake. Binance Smart Chain also uses a form of proof of stake, and I believe they also use another consensus mechanism called proof of authority, where they have a limited number of validators to submit transactions and verify them. But in Solana, their version of proof of stake work as follows. So in a given epoch, which is around 2 days per epoch, a leader is chosen, and that leader is no different from any other validators within a given period of time, and it gets selected to basically order the transactions. And the rest of validators are basically a group of nodes that verify the block that is generated from the leader. And I'm going to get into proof of history, which is simply a high frequency of verifiable delay function. And they use this function to verify the transaction from the proposed block by the leader. And if the result were 2n plus 1, n is a arbitrary variable here, where if it equals a honest number of nodes and m equals the malicious nodes, then the block becomes valid and it is finalized. So this equation basically leads to the point that 2/3 of the nodes have to be honest. So a mechanism of slashing has to be implemented so that if a validator, supposedly a malicious validator, votes for a block that has been proposed by a malicious leader. Since when you are staking to participate in a network, depending on the network, you would have to stake their own native token. For Ethereum, you would have to stake Ethereum or Ether. And for Solana, it would be Solana. But so far, since it's in mainnet beta, Solana does not require a fixed amount of SOL to be staked in order to participate in the network, whereas Ethereum, they proposed a rule where you have to stake at least 32 Ethereum in order to participate in the network. And as I said before, since Solana is still in mainnet beta, they have not implemented the slashing mechanism. So, but I believe in Ethereum, the minimum amount of ether that gets slashed, it's at least 1 ether that gets slashed. So I'm thinking Solana maybe do something similar to what Ethereum is doing, but that's just it's just a speculation. So let's go back to what verifiable delay functions are, which is the core innovation behind Solana's proof of history mechanism. So this took me a while to understand, but the theory is pretty simple. The function that we are computing basically has to be exponentially greater than to verify. So in Solana's case, since Solana uses SHA-256 algorithm, secure hashing algorithm, to generate its hashes, the function, the SHA-256 hash function, can be computed in a linear time. And obviously there is a delay, right? Because it takes some amount of time to compute the function. However, during the verification phase, it can be parallelized, meaning that it can be verified at a far greater rate than its computing rate. So that's basically what verifiable delay functions are. And this is how Solana achieves to organize the ledger. So this is an analogy of what basically the definition of verifiable delay function can be. So 100 people, one by one, reroll dice placed in a dark room. After the last person lights turn on, revealing a fair random number. The VDF here ensures that the lights aren't turned on early. So here is the block explorer, one of the most used block explorer in Solana. So hopefully you guys can see my mouse pointer. So we are currently at epoch 370. Okay. And we see that the epoch is at 33% complete, and the estimated time for it to be finished is a day and 14 hours until the next epoch happens. And we see that the slot height is at 159 million. So during this phase, as you can see at the bottom, every single leader is pre-chosen before this 370 epoch even happened. And as you can see, all the leaders are equally distributed across the globe. We got some in Asia, Europe, and US. And each leader, they basically rotate and they get to order transactions on their for their destined slot height, right? And you guys can see the current TPS, which is transaction per second. It's around 1100, and total transaction is 113 billion. So this is how it works, really underneath the hood. So users on the client side, they send a transaction, and then it goes through the leader, which you saw from here, and it goes through the POH, or proof of history generator. And what proof of history guarantees is that after each transaction is ordered, proof of history guarantees that there has to be at least some time spent in order to go through each SHA-256 algorithm in order to generate its resulting hash. And in Solana, they call this entry ID instead of a block hash or Markov roots in Bitcoin or Ethereum. An entry ID is basically a pre-image resistant hash over the final contents of an entry, which acts as the entry's global unique identifier. And the hash includes the entry being generated after a duration of time, the specified transactions, and basically the entry's position. And after the states have been reordered, or not reordered, after the transactions have been ordered by the leader, as you can see, it goes through the verifier, and the verifier verifies the transactions using the verifiable delay function, and it produces a state hash. So one of the main reasons why Solana blockchain can produce such high transaction per second is due to the fact that things can be parallelized. So as you see here, this process that you're seeing after the leader orders the transactions, and basically those transactions have to get sent to each verifier, right? And obviously, according to this diagram, there seems to be only 2 verifiers, but in Solana's case, there's hundreds, if not thousands of verifiers that are waiting for transactions. So they figured out a way to basically parallelize this process by having like a tree data structure where the leader sends a sample of the ordered transactions onto the quote-unquote neighbors, which contains the validators who are trying to verify the transaction, and the neighborhood kind of gets passed down. So that creates like a parallel structure so that transactions can be received and sent for verification at a very fast rate. And obviously there can be room for failures since, as you saw, Solana generates a lot of data since they're verifying from anywhere from 1 to 3,000 transactions per second. We're talking per second, not per minute. This means that there can be malicious verifiers, or there can be some verifiers they can basically have slow internet, so they might not receive the full amount of transactions, or maybe it's too late for them to verify those transactions. So there can be case where not every validator sends the transaction back to the leader after they vote whether the sample transactions that they got were valid or not. So they introduced this feature where I believe it's up to 30% of transactions can be formed into parity chunks using Reed-Solomon. I haven't really looked into that, but basically up to 70% blocks can be received in order to become a full block, or a whole slot in this case. So up to 30% can be omitted, and it can be dynamically adjusted depending on the network condition. And here we're looking at another diagram of how client sends the transaction onto the remote procedure called server, and it uses UDP to send those transactions to its according validators who are given a fixed slot times for them to become the leader in a given epoch. And in Solana, like I said, things are parallelized, so they have this pipelining phase. So they start from the fetch cycle from the kernel space, and they move all the way down to GPUs. So fetch happens on the kernel section. And one of the things that the verifiers do is they verify whether the signatures are valid, right? Whether the signatures have been signed by its private key owner, those that are submitting the transactions. So GPU actually uses, so to verify signatures, Solana borrows power from GPU to perform this task, and it moves up, and on the CPU section, it goes through the banking phase. So that's when, I believe this phase is when, depending on the transaction, it gets the amount of Solana or whichever cryptocurrency it may be, it gets credited to its right account. A recipient, and it gets right up, and then it gets posted onto the Solana blockchain. So here's more of a detailed overview of how that works. So you see the fetch stage, and the banking stage, and it gets recorded on the proof of history service, and it gets broadcasted to its verifiers. And building programs in Solana is quite complicated. So everything on Solana is in the form of accounts. So you got program accounts, storage accounts, and token accounts. And there are two types of accounts on Solana blockchain. One is executable, and so it's either executable or non-executable. So program accounts are executable code and the equivalent of Ethereum smart contracts. And depending on your use case, you can build a program account and have storage or token accounts be attached to the program account for a use case. Now, this might introduce a very high learning curve of building programs in Solana. However, this is seen as very memory efficient. And is also written in Rust or C++. And it gets compiled into bytecode via the LLVM compiled infrastructure. In Solana, there is also a feature of rent. Since storing data on the blockchain is not cheap, Solana makes developers pay rent according to how much data it's taking up on its according accounts. So as you can see, when we run this Solana command, when we run Solana rent 32, we see that the rent exempt minimum is 0.001 Solana. So this is the key here. So rent exempt minimum means that if an account has at least this much SOL in the account that stores 32 bytes, that account is rent exempt, basically. So if you want all your accounts to be alive, you need to have at least the minimum amount of SOL. So I believe this is this calculation. This calculation is, I think, 2 years worth of rent. So after 2 years, they count it as rent exempt amount. So the amount of SOL that you'll be paying will be for 2 years. And on the right side, you'll see some of the identifiers for the Solana account for Alice token in this case. So you see the public key, the amount of SOL it has, who the owner is, and whether it's executable, since we know that token accounts, only program accounts are executable. In this case, this account is false for executable, and it's currently residing at rent epoch 268, and the length is 82 bytes. Now, scalability is great. You know, transactions are cheap. Blocks are produced every 0.4 seconds. However, there are downsides to that. And it's due to the fact that, there are many downsides, but the selection algorithm favors the highest stakers. So what I mean by that is, when we look at how the leader distributes its sampling transactions to its neighborhoods, the validators that have the highest number of Solana tokens staked, they get to be placed at a closer position to the leader. So that can be a form of centralization.
I'm kind of confused on exactly like the concept of neighborhoods. Like,
it's just the grouping. It's not really. It's just a way to
So,
group
like,
validators.
so why is it more efficient to have like groups of these?
Because when a leader is sending transactions, the ordered transactions to validators, they're not sending the entire ordered transactions to each validators. They are essentially given a sample. And the way they distribute its sample transactions is in this form. That's how I understood it. So I'm probably guessing that if this if the leader's total order transaction is 100 bytes, then it gets split off into 50-50, and then so it'll be 50-50, and then it will be 25-25, and then so on and so forth, depending on the lowest, depending on what the protocol's lowest distribution size is, which I couldn't find actually, but I think that's how it works. Hopefully that answered your question. And since any validators can become potential leaders, there can be another form of centralization where the selection algorithm favors the high stakers in a case where, let's say you are delegating your staked amount to a validator. And let's say you own 80% of the total share. That means that when that validator that you're delegating to becomes the new spot leader, that means that the leader is most likely going to prioritize your transactions first over any other transactions that have been submitted in that given slot. And there's also another downside. So if someone wants to maintain a full archival node for Solana blockchain, it is nearly impossible for normal people. So let's look at the hardware recommendations. They require at least 12 cores, 24 threads. And they require 128 gigabytes of RAM or more. And they suggest 256. And the disk is also very highly spec'd. They require at least a Gen 3 NVMe SSD or better. They also require a lot of data or storage. They say that the Samsung 970, 980 Pro, which are the latest NVMe SSDs, are popular. So that means most people are using that. And it says that GPUs are not strictly necessary at this time. And I think this is only because currently not many people are using Solana blockchain, since in the Solana whitepaper, Anatoly gave a statement where Solana can theoretically reach up to 710,000 transactions per 400 milliseconds, so per 0.4 seconds. So this means that if you go back to the diagram, second. So after the fetch cycle, probably we're going to see a major throttle. When we see more user activity, it can be a major DeFi application, NFT marketplace, whatever it may be. The GPU will be heavily stressed when it has to verify more signatures, given that there's going to be a lot of people who will be using the network. So yeah, that's another downside. And the last one is obviously Solana, the entire network being halting. So Solana blockchain has faced, according to this article, 7 times of outages in the year 2022. And I believe the main attack is DDoS attack. So these bots, they basically artificially clutter the network. And since everything is parallelized in Solana, everything is parallelized, meaning that when we're looking at a given epoch, so currently the epoch is 370, while this is happening, before it gets transitioned to epoch 371, its leaders for epoch 371 for the allotted slot, for a given allotted slot, is predetermined before the next epoch happens. So every calculation is done in advance, so that the blockchain can process more transactions. I think that's basically what it is. And Solana also uses UDP protocol, so there can be situations where the validators can see a loss of they may experience packets dropping. So that means that they may not receive some transactions depending on the individual validator's internet latency, speed. Because according to the Solana white paper, the benchmark that they did for their claimed number of transactions per second, they assume that every single validator has a gigabit internet or gigabit Ethernet speed, as well as having a minimum of a GPU card that has 4,000 cores. So that the benchmark is pretty unrealistic, given that I doubt that not every validator has met that spec, especially the internet part. So that's probably why Solana is experiencing a lot of outages. So, it's still in mainnet beta, so they still have a long way to go. I mean, this blockchain literally came out 3 years ago. So, yeah, I'm overall pretty bullish on Solana blockchain. Let me know what you guys think. Any questions?
I have a question actually.
Sure.
Could you maybe elaborate a little more on the GPU component? Like how would that work if you, because I know you said that it's not mandatory at this time, but like if you
Oh,
were to
the
configure it with the GPU, what would that entail?
So first of all, I could not find a lot of information to actually conduct a thorough research on Solana blockchain. I think I spent like cumulative time of like 20 hours for this presentation, and
Oh, okay.
the GPU part was very vague in my opinion.
Okay.
Yeah. I mean, if you really want to, I can definitely do more research and tell you at a later given time.
Yeah, no worries. I was just kind of curious.
Okay.
Yeah, but yeah, interesting talk.
Thank you. Any other questions?
Just wondering if you could quickly explain DDoS attacks.
The what steps?
We were just asking if we could get a quick explanation on DDoS attacks.
Oh, I actually didn't do research about how the attack happens. I mainly did research about how the blocks are propagated in Solana, since that's like the core technology behind how Solana works. Yeah, I actually don't know how they managed to I guess organize the DDoS attack. But based on my knowledge of how Solana blockchain works, it's probably due to the fact that everything is calculated in advance to allow parallelization to happen. On top of that, parallelization happens. So if something goes wrong in between, then the entire network has to halt. Basically, they have to restart. Because I forgot to say, but you see, after the transaction gets submitted back to the leader, and if the vote is higher, so I mentioned here, so if there are at least, if the majority of nodes agree on having this block as valid, then it goes back to the leader, and the leader is the one that they're the last ones to basically finalize the proposed slot. But Solana also has implemented a neat feature where, what if the leader is not active? Then what happens, right? Because there's obviously, like, I don't know how many leaders are here, but there's obviously hundreds, if not thousands, of leaders in a given epoch. And who knows, right? One of the leaders might not be active. So they implemented a feature where they basically, if the leader is not active, they have a rollback function. So they will basically roll back to its previous state if the leader is not active, and they would move on to its next leader. So that probably has to do with something in regards to DDoS attacks. Maybe the Solana blockchain couldn't handle the amount of data it needs to digest in order to form its block on each slot. And since there is some kind of voting mechanism behind this, where it takes exponentially longer time to roll back to its previous state. So that, I think that might have caused the network to halt. Sorry to answer your question. It's a really complicated phase or system.
Oh, Byung, sorry to let you know, but we have about 5 minutes left. We're 12:50.
Okay. I can give resources to what I've used. So maybe you guys can check that out for yourselves. That might give a clear idea on maybe how it alludes to being vulnerable to DDoS attacks. Any more questions?
Sounds like maybe you can go and show the resources to learn this stuff, because this is a very advanced presentation.
Yeah, this is all the research that I use.
Yeah. Also maybe talk about the research team too, for anybody who is interested.
The things I will be doing it won't be as difficult as this. But yeah, for our research team, you'll be just conducting a research on a topic of your interest, or I can give you a topic and they'll be published under our CPP blockchain team account, I guess. Yeah. At the end of the semester, that is.
Sounds like we're good to go. Yeah, but really appreciate everything you've been showing us. This is a very advanced presentation. Wow.